What is refraction of wave? Refraction of wave is the change in direction of propagation of waves caused by the change in the velocity of waves when the wave propagates from one medium to another medium. Speed of water wave is influenced by depth of water, while speed of sound wave is influenced by density of air, and speed of light wave is influenced by optical density of a medium.
Experiment to investigate the refraction of water waves. The materials and apparatus. We need ripple tank, wooden bar, motor, lamp, perspex plates of different shapes, mechanical stroboscope and white paper. First, a ripple tank is set up as shown below. Second, the tank is filled with water and the legs of the tank are adjusted until the depth of water in the tank is uniform. Next, a perspex plate in the shape of a trapezium is immersed in the center of the tank to create a shallower water region in the tank. After that, the motor with the wave beeper attached is switched on to produce plane waves. The propagation of the water waves in the deep and shallow water regions are observed using a stroboscope. Steps 3 to 5 are repeated with the orientation of perspex plate change so that the wave is incident at an acute angle to the side of the plate. Steps 3 to 5 are repeated using perspex plates in the shape of triangle.
So here are the results of experiment. Discussion of experiment. Refraction occurs when water waves travel from one area to another area with a different depth. If the incident wave strikes the perspex plate at 0 degree of incidence angle, the waves are not reflected. If the incident wave strikes the perspex plate at a certain angle, the water waves are reflected. The water waves are refracted towards the normal if the wave travels from a deep water region to shallow water region. The water waves are refracted away from normal if the wave travels from a shallow water region to deep water region. Conclusion. The direction of propagation of the wave will change if the angle of incidence of the waves is not zero. The shape of the refracted waves depends on the shape of the shallow water region over which the waves travel. Drawing diagram of refraction of plane water wave from deep water region to shallow water region. Firstly, draw an arrowed line perpendicular to incident wave front to represent direction of propagation of the incident wave. After that, draw the normal which is perpendicular to the boundary of deep region and shallow region. Next, draw an arrowed line which is bent towards the normal to represent the direction of propagation of the refracted wave. Lastly, draw the lines perpendicular to the refracted wave line to represent the refracted wave front. The lines have to be closer to one another compared to the incident wave front.
From shallow water region to deep water region. First, draw an arrowed line perpendicular to the incident wave front to represent the direction of propagation of the incident wave. Next, draw the normal line which is perpendicular to the boundary of the shallow water region. After that, draw an arrowed line away from the normal line to represent the direction of propagation of the refracted wave. Then, draw lines perpendicular to the line to represent the reflected wavefronts. The lines have to be further to one another compared to the incident wavefronts. Effects of refraction from deep water region to shallow water region. Effects of refraction from shallow water region to deep water region. Phenomena of refraction of wave in daily life. Sounds during the day. During the day, air that is closer to the surface of the earth is hotter than the air above. This can cause the sound to move faster in hot air than in cold air, and the sound is refracted away from the ground. Thus, an observer cannot hear sound clearly during the daytime. Sounds during night. During the night, air that is closer to the surface of the earth is colder. This can cause the sound to reflect towards the ground, and the observer can hear the sound more clearly during the night.
Refraction of sea wave. The cape is the shallow water region while the bay is deep water region. Away from the shoreline, the wavefront of water is almost straight and parallel because water moves at uniform speed. When the wavefront of the water propagates to the cape, the speed of water wave decreases, causing the wavelength to be shorter. Wavefront of water approaching the bay move at a higher speed and the wavelength is longer. This causes the wavefront to curve and follow the shape of the shoreline. Refraction of water causes water wave energy to converge towards the cape. Water wave energy diverges from the bay and spread out to a wider region. Thus, the amplitude of wave at the bay is smaller than at the cape.
Let's derive the formula. From the formula of speed of wave, we can get a formula V equals to F times lambda. V is velocity, F is frequency, and lambda is the wavelength. For example, in deep region, the equation is V1 equals to F times lambda 1. In shallow region, the equation is V2 equals to F times lambda 2. When we divide equation 1 and equation 2, it gives new equation which is V1 over V2 equals to lambda 1 over lambda 2. As we simplify the equation, we can get the new formula, that is V1 over lambda 1 equals to V2 over lambda 2.
Now, let's answer a question. A plane wave has a wavelength of 2 cm and a velocity of 8 cm per second when it travels over a shallow water region. When the plane wave travels over a region of greater depth, its velocity becomes 12 cm per second. What is the wavelength of the wave in the region of greater depth. Now let's do it. For shallow water region, we can detect the V is 8 cm per second and the lambda is 2 cm. For deep water region, the velocity is 12 cm per second and we have to find the lambda. Calculate by using the formula and the answer is 3 cm.